Waalaikumsalam warahmatullahi
Sir.
wabarakatuh. Good
Yeah.
afternoon, sir.
Yes, good afternoon, everyone. Hoping that you are doing well. And sorry for being late because I just arrived at home. The scholar a bit longer, so yeah, I arrived at home a bit late. Okay, anyway, thank you very much for waiting, and we continue, yeah, with our clarification. I mean, my summary about the topic for this week. Yes, last week we already discussed about the overview, yeah, statistical inference, samples, populations, and the rule of probability as well. And let's start with the sampling procedure and collection of data. Yes, if we, yeah, last week, I mean, not last week, but yesterday, a bit remember, yeah. Okay, anyway, actually, when we have a population here, yeah, populations, because of limited resource, I mean, limited time, limited cost, yes, we have to conduct sampling. Yeah, but we have to make certain criteria to do sampling. The important criteria, should be fulfill the randomness. Yeah, we have to make a randomness. Means that based on the randomness, we expect that we can capture all of the information in the populations. For example, this is Indonesian population or Indonesian, yeah. Indonesians consists of 270 million, yeah, million people, yeah. And then we want to know the information about the income, income per capita, income per capita. So to fulfill the randomness, we should sample proportionally from Sabang, yeah, Sabang to Merauke, yeah. Sample proportionally from Sabang to Merauke. Maybe we want to sample 100, yeah, 100 people, yeah. We should pick up, for example, based on the NIK. NIK is nomor induk kependudukan, citizen number. So we have to provide this NIK along 270 million people, and then we should generate or pick up, yeah, pick up until 1,000 NIK randomly. Yeah, this method we can say random. Yeah, if we take the data from the population data. Okay, I hope it's clear. Maybe somebody asking about what kind of criteria that not full the randomness. Yeah, for example, we want to say the Indonesian people for income per capita, but we only take sample in Jakarta. In Jakarta, we cannot say, yeah, we cannot say that when we sample the income per capita from Jakarta, that after we got the data result, we cannot say that this is the income for Indonesia. Means that the proportional of the sample is not good enough, because that's only in Jakarta. From this case, you can only say that this is maybe the income per capita in Jakarta area. That's okay. That's okay. You should mention the Jakarta, the location, the data you taken. Yeah. Okay. That's kind of randomness. In another sample, maybe the how to say, the data, the pattern, yeah, the pattern of the income per capita in Indonesia is really different. Maybe if you can see, for example, this is map of Jakarta. This is map of Jakarta, and this is Sumatra, for example, and this is Jawa, and this is Sulawesi, and this is Bali Nusra, yes, for example here, and this is Papua. Okay. For example, the income in Jawa is relatively higher. So the population in Java Island might be greater than 50%, and the income is maybe how to say, maybe relative higher, like let's say 10 million rupiah. For example, in here in Sumatra, maybe only 3 million. In Kalimantan, only 1 million. In Papua, maybe only 1.5 million. And this is only, how to say, maybe 2 million. Yeah, this is just as an example. From this point, if we took the randomness, it is there is a possibility to take that the data come from Java. It is possible that the data you took comes from Java only. Yeah, because of random. And because of that, because the only Javanese people that we took, it is not possible. I mean, it is not reflect the entirely Indonesia. You can see maybe this is 10 million rupiah. So the data will be on average 10 million. But reality in Sumatra, Kalimantan, Sulawesi, and Papua, much lower than in Jawa. you can see that this is, if we take an average 3 plus 1 plus 2 plus 1.5, it's going to be 4, and 3.5 is 7.5 divided by 4 is less than 2 million, right? It's less than 2 million. That's why, so what is the solution about this case? The solution is make strata random sampling. It is more makes sense. It means that strata is a level kind of level. Random is random, sampling is random. Random sampling is just a random sampling. Means that in this case, we should take the data. We should separate the data into two sections. First, Java section, and the second is not Java section. Not Java section including Sumatra, Kalimantan, Sulawesi, and Papua. And then because the population in Java is 50%, let's say is almost 50%, and the other not Java is 50%. So we should take 50% data in Java, means that around 500 data, and for not Java also 500 data. From this case, this method is more reasonable to get the real data about the Indonesian income per capita. Any question? Any questions, sir?
For now, no, sir.
No, sir. Okay. Okay. Now, the method for random sampling, you can see this is a pure random sampling, and this is the strata random sampling. Wait. This is pure random sampling. This is strata random sampling. How to take, like maybe first in this case we have to group. For example, this is NIK from Java. This is NIK not Java. And then after that, you generate sampling. This kind of method, this kind of procedure, we can say experimental design. So the experimental design is the way you generate the data, something like that. Okay. Let's move forward. Okay. Talking about the statistical data, in this case is a sample data. Sample data. The thing that mostly we want to know is sample mean. The second is sample median. Sample mean, it is very straightforward. Just sum up together all the data and divide it by n. This sample mean reflect the centroid of the data. Yeah, centroid of the data. You can see, for example, how to say, for example, what? Yeah, again, income per capita, for example, and this is specific in Jakarta. You make a survey for 100 people, yeah, 100 people, and you got this kind of data. This is from 10 million. No. This is a frequency, the number of people, yeah, and this is the range data. Let's say from 10 million until 500 million. And you got the data being like this, which is the average is, let's say, maybe 200 million. This is usually this is the mean, yeah. Actually, the mean reflecting that usually the most frequent number. Okay, that's the sample mean. Okay, and the median is the center value, yeah. Actually, between this point 500 until 10, the is 490 by 2, it is 245 million. So here 245 million, this is a median. Actually, the median is less minimum or meaningless compared to the sample mean here. Usually, most of people, when we talk about the data, asking about what's the mean of the data. Actually, because the mean of the data reflecting the common people. The common people, I mean the common data, which the location is common data. What is the location? What is the common value? Yeah, something like that. Okay, anyway. Okay, and this is a sample median. So these three kind of distribution model that might be occur. This kind of maybe starting from this one, the B1, means that if we make a straight line in the center, the area between left and right is equal. AB is equal to B. And in this case, usually the mean is equal to the median. But in this case, usually the mean here, this is the mean, and the median is here. Usually the mean less than the median. In this case, yeah, just opposite, the mean is greater than median. Okay, that's all. And the another parameter, first we already know mean and median, and then the next variable is variance. Okay, variance. Actually, what is the variance? Variance is the degree of difference between each data. Degree of difference of each data. That's why we can say variance. You can see, because the difference, so this data should be, how to say, should be measured with some reference, right? Should be measured with some reference. In this case, the reference is mean. This is the mean. So after we take the difference, a data with its means, we get the value, but the differences could be positive and negative, right? I mean the xi minus the mean, it could be positive and could be negative, right? And if we sum up together, if we sum up together, the negative and positive will be canceling each other. So that's why we put power by 2, to make it absolute. So the difference is either positive or negative, cannot canceling each other. We keep those data by power by 2, so become positive all, and then sum up together, and then we make average based on the number of the data here. Yes, we got the variance. Actually, that's the meaning, the philosophy of the variance. But if you don't want to take the philosophy, you can just compute by using this formula. Actually, remembering this formula is just only for senior high school, because we are in undergraduate in high educations. So it is better to you to know the philosophy of this formula. Okay, the standard deviations. Standard deviation by the formula is just a square root of the variance. The motivation for computing standard deviation is to get the same unity with the data. You can see here, the data is powered by 1, but the variance is powered by 2. It means that the variance is not equal. Not equal. It is proportional, but not equal, because this power by 2, this power by 1, but the variance is powered by 2. So to take the equal unity, we should make square root. For example, here we measure the voltage of from PLN. From PLN. Resource from PLN, we measure that we got let's say 220 volt, right? And then we make a measurement again, 221 and 222. Okay, so we measure the mean. The mean is just sum up together, and divided by 3. So the result is 221, right? 221, and then we want to make we how to say, we want to compute the variance. Okay, variance actually as as power by 2, and then the result is xn. Okay, the result is so 220 divided by 1 is 1 square plus this divided by subtract by this is 0, and plus this subtract this one and 1. Okay, that's all, and sum up together, and minus by 1, it is equal to the 2 by the n is 3 by 3 minus 1 is equal to 2 by 2 equal to 1. Okay, equal to 1, but in this case equal to 1 should be voltage. Yeah, the unity is should be voltage power by 2. After we square, yeah, we square root, we got the unity because the voltage something like this is the unity is equal to the this one equal. Yeah, that's the motivation of making variance and making standard deviations. Okay, that's all. Let's move forward. Okay, when we generate the data, kind of classification of the data is continuous and discrete. The opposite of continuous is discrete, of course. The definition of continuous data means that the data is always available in any time, in any condition, depend on the domain here. Let's say this is a time. So the data is always available anytime. Okay, anytime you can see the black curve here, the black curve. You can see, for example, this is from 0t, and this is let's say in here is 10 second. 10 second. Means that this is maybe is 9 second. Yes, 9 second means that when we take time at the 9.5 second, the data is available. You can see here, let's say this point 9.5. So you can take this data here. You can extract. Yeah, that's the meaning of continuous. Compared to the discrete, data discrete means that data is available in certain period, but not anytime. You can see after discretization. Discretization. I don't know whether it is this word is available or not. Okay, but anyway, you can see here after discretization. The discrete after the sampling, yeah, after the sampling, you only have the data in this point, in this point, in this point, in this point, in this point. And when you, if you want to know the data at time t equal to 9.5 seconds, the data become not available. Okay, that's the point. That's all. Okay, let's move forward. Statistical modeling scientific inspection and graphical representation. Okay, what is the relation of from these three phrase, yeah, statistical modeling, scientific inspection, and graphical representation. Okay, let's get from here. Statistical modeling. Statistical modeling is kind of model. Kind of modeling. Model of what? Model of sample. Sample of what? Sample distribution. You can see this is data. This is data sample, for example. And then from the data, because of random, you remember we always talk about the randomness. So because of random, the frequency, we can draw some graphical representation here. Yeah, from this is the spectrum of the data or sample range, and this is the frequency. So you can see here, we can always put them on some, yeah, some model, some mathematical modeling, yeah, something like that. You remember this graph is really how to say, no. If you're familiar with this graph, what is the name of this graph? The name is the graph is Gaussian distribution model. Yes. The form of this graph is being like this. Okay, so that's the model. How the model the data sample? What kind of model the sample data? Okay. Then we move forward here. This is the scientific inspections. Actually, when we take the sample procedure, how do we collect the data, how we can model the data? Actually, we should, I mean, we conduct based on assumption. And this assumption should be made by scientist expert. Means that this assumption should be logic and proven. Yeah, it is not good for sampling or modeling the data without considering the real phenomena. For example, when we sample the data, let's say I want to sample the income per capita of Indonesia, it is not make sense that if we sample only in Jakarta, we should make sample to whole Indonesians, something like that. That's the kind of scientific inspection, or assumption that can be validated. Okay, the next is, after we get the data, we should show, we should represent, we should presenting in some kind. In this case, in graphical representation, means that why we should present in graphical representation for being easy to read. Yeah, so when we read the data in terms of graphical representation, it is more easy to read rather than the data is just collecting data. Reporting data is this is a data that we took from the population and you list all. There is no meaning. there is no meaning. So you should put or proceed the data into some graphical representation. In the first meeting yesterday, I already check everyone by giving your pretest like a histogram. Histogram is kind of graphical representations, and other graphical representation like a scatter plot, box plot, and etc. Those things, we gonna discuss later. This kind of scatter plot, this is kind of box plot. Okay, move on. I think this is the last slide for today. And so, talking about the statistical study, there are at least 3 types. Three general types. 3 general types. I should point out here, general types means that every method, every framework can be classified into one of 3 types. First is design experiment. Design experiment means that we sampling the data. We sampling the data from the experiment. You can see here, this is the experiment of measuring the measuring maybe the current flow through this circuit, and you can make continuous measurement or discrete measurement. But the point is, this measurement is taken from an experiment, from design experiment. Means that this experiment should be designed. For example, we should determine the value of source. We should determine how much the load, how much ohm, how much ohm the load, or we can change with another load, kind of capacitor or just a resistor, something like that. So every point here, every sub experiment, we can control. We can control, we can change, something like that. Okay. Okay. And then it is really opposite to this observational study. The observation study, the differences between design experiment is, in observational study, we cannot control the parameter. We cannot control the parameter. We cannot control the example of observation study is like this is measuring the evaporation. 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 I think I should make a different color. Okay. Okay. You can see this is this kind of result. Actually, the y-axis, this is the percentage of evaporation. Percentage of evaporations, and for the x-axis, this is the month. the months. Yeah, this is the 11 month, and starting again 1 month, 2 months, February, March, April, and so on and so on. And this is the condition of the tree. Yeah, the condition of the tree. When in December, in around December, the evaporation is around 80%, around 80%, and because of this, the tree is like no leaf, no leaf, and then makes increasing in February and become maximum in February. The evaporation is the highest, so the tree is drying. Yeah, okay, and then decreasing in March and get the minimum evaporation, in this case reflecting the number of tree, the number of leaf here. Leaf of tree here is really big. I mean, the number of trees is really high, yeah. And but the evaporation increasing again, starting at the September, October, and November. So the tree is getting dry again, something like that. And means that this evaporation and this result, I mean this phenomena, we cannot control. We cannot control. Yeah, we cannot control the evaporation at the soil, right? We cannot. This really merely by the nature, from the nature, given by the mercy from the nature. Yeah. Okay. Okay. Even from this number of leaf at the tree, yeah, and the tree is we cannot control. We just observe. Yeah, we just observe, we just see and make a relation between evaporation behavior and the tree behavior. So that's all about the observational study. And the third is retrospective study. Yeah, retrospective study. Okay, sorry for difficulties pronounce. Okay, I put here. This is real time. This is a gold price for today. Yeah, for today, gold price for today. Yeah, you can see I took the data for 3 months. Yeah, this is actually starting from 3 months later. 3 months ago. 3 months ago, and you can see the trend of the data is increasing and then decreasing. What is the point from this? This is the kind of retrospective study. It means that we collecting the data from the past. We collecting the data from the past. Okay. It's similar to observational study, means that the similarity put on that we cannot control. We cannot control the parameter. We just receive the data, the incoming data we receive, and then we observe. We analyze. We proceed, something like that. Okay. Okay. That's all for the clarification for today. So it's time to discussion if you have any questions.
So I have questions.
Yeah, okay. Hanif can go first.
Okay. Okay.
No, go first.
Oh, okay. So I have a question. Is there any books reference that we can use for learning?
Okay, of course.
Like the name of the book?
Yeah. Wait a moment. Wait a moment. I'm opening the mass. I'm opening the mass, yes, and probability and statistic, and then okay. I will stop share screen and then I will make a different. Okay, and then okay, you can see from the page from a mass, you can download from here topic distributions and the course description that yesterday I discussed with you, and at the end of this course description, there will be many reference here that used in this course. The primary reference is number A. The another is just a supplementary material, yeah, supplementary reference. You can yeah, you can use this book here actually.
Okay, sir. Thank you.
Okay, good.
Excuse me, sir.
Yes, please.
Can I ask a question as well? I have two questions. Is it okay?
Okay, this is okay. 2 questions, 5 questions is okay.
Okay, sir. Okay, so the first one is I actually still don't quite understand the standard deviation and variance. Is it like too much of a trouble if you can show us an example of usage of standard deviation and variance? And the second question is in the scientific inspection part, it says that modeling is formed by assumptions. So like, does that mean like all data that exists from statistics is not 100% accurate, but like very close because, or made by, you know, like the assumptions is like scientifically like, or I don't know, made by scientists. Is it like that, sir?
Okay.
That's the question,
so maybe the second question is about what is the relation between the meaning of assumption and scientific reason, something like that.
Yes, sir.
Okay, okay. I got it. Okay, okay. Anyway, what is the question about this variance and standard deviation? Sorry, I don't get your point.
I think actually I just want to like know like probably any example source or like how variance and standard deviation is used.
Oh, okay, okay, okay. Okay. Actually, the meaning of variance and standard deviation is the meaning, yeah, the meaning. Not how to say. The purpose, yeah. Purpose to compute the variance or standard deviations is to show homogeneity of the data. Homogeneity of the data. Okay, let's say okay, for example, we have after what to say score of evaluation, score of evaluation. We have this is first class. This is the second class. Okay, and let's say we have a 5 data each. For example, the first class, someone get 20, someone get 50, someone get 55, someone get 100, someone get maybe 60. Okay, and in the second class, someone get 70, someone get 72, someone get 75, someone get 85, someone get the 68. Okay. Okay, and then we draw the data. We draw something like this. Okay, first is we have to make a sum up together. Sum up together, it should be, we can compute 7 ini 7 tambah 3 itu. Somebody can help me. What is the total here?
The total of each cluster.
First class.
285, sir. 285.
285, sir.
285.
85.
And for, how about this one?
370, sir.
3.
Yeah, 300.
And
what?
No,
For the first class.
the first
The
class
first
is
class is
285.
200. The second class is 370.
Okay, please divide it by 5.
It's 57, sir, for the first class.
57. About this one?
74.
74. Okay. 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 Let's make this is xi minus this one. It should be, this is xi minus this one. Means that 20 minus wait a moment. I think it's better to make an Excel. Is easier. Sorry. I will make an Excel. So first class 20, 50, 55, 100, 60. Okay. Second class 70, 72, 72, 75, 85, and 68. Okay, the total is sum this one. Okay. Total, okay. And the average is this one divided by 5. This one divided by 5. Okay, good. And then we should make xi minus min first class, xi minus min of second class. Okay, okay, so in this case, it should be this one minus 75. So, okay, good. And this one minus 74. Okay, good. So in this case is variance of first class. This is variant of second class. The variant is should be that this one, right? And this one, it should be this one, and this one, right? Okay. Okay. And then sum up together. Divided by 5. From this point is in okay. Please take a look from this data. The first class is the data is like this. For how to say, for quick view, what is the difference between the data from first class and second class? Who is asking?
Yes, sir.
Eddie? RD?
Yes, yes, sir.
Yeah. For first seeing, by looking at the data from first class and second class, what kind of information you can say?
The second, wait, the average of the second class is higher than the first.
Okay.
Mhm.
And then
Uh,
please look at only this data.
oh, okay. Well, I don't know. I think for the gap between the score in the first class is higher.
What is the meaning
Then
of gap? You mean gap?
I think if the gap from the lowest score to the highest score.
Okay. So you mean the spectrum, the range?
Yes, the range, sir. Sorry, yeah.
Okay. In terms of range, class is higher about the second class.
The second class has higher average.
No. In terms of range.
Oh, the range is closer.
Closer. Okay. Closer, higher. Up to you, the word that you use. But I mean, the point is that you understand about the difference, right?
Okay, sir. Yes.
Okay. I agree with you, but this first class, the range is higher, starting from 20 until 100, right?
Yes.
Okay. From the second class is starting from 68 until 85. Means that the data how to say? Wait. If I draw, let's say, okay, wait. Okay, this is first class, and this is the second class, and this is first class starting from 20. Let's say 30 and something, and then we got 100 here. So it is equal to this one. So the first wait. I think okay, first class is here, is there is, and here, and 55 is around here, let's say. So 100 here and 60 around here. So we can write like this. Okay. And for the second class is around 60, 70, 72. Let's say 70, more than 70 is here. 72, 75, and then the 70, 75, 85, and then here is for 68. Yeah, you can see here the distribution of the data for the first class is spread with wide spectrum, wide range. But for the second class, you can see the availability data from 70 until 90. Yeah, it is good. I mean, in terms of range, the class 2 is closer. Yeah, okay. And then this kind of behavior, the data distribution, we can measure by the variance. Okay, the variance. You can see here, for broader range or wider range, the variance is greater. Yeah, is higher. Okay, is larger. Okay, variance is larger. But if the data, the range of the data is closer, the variance also smaller.
Okay, okay, sir.
Okay.
Oh,
Okay.
okay.
Yeah.
Okay, so,
okay, same phenomena also when we compute the standard deviation, because the standard deviation is only, I can write here standard deviation just square root of what, this one, and also we get the similar trend that the standard deviation for the first class is higher than second class. Okay, that's the point. Okay, any unclear explanation, please?
okay, so I think I understand. So like the variance and standard deviation is to show just another way to show the data that it has like shorter or longer range of data. Okay, sir. I think
Yes.
I understand it a little bit more. Thank you.
Okay. And then for the next question is around about the scientific inspection here. Okay, wait a moment. I'm thinking the next sample. When we are talking about, wait a moment. This one. For example, in this circuit, we want to measure the can you see the oh no, I'm sorry, I'm not showing. This one. You can see here, yeah, my PowerPoint, yeah.
Yes, sir.
About the assumption and relation between assumption and scientific reasoning. Okay. Wait, this is okay. In design experiment, for example, we take an example from this kind of design experiment. So when we want we have the circuit. The circuit is being like this. We have one DC source and one load here. So our job is how much the current flow. The current flow. And then the scientific reasoning from this purpose is how to measure the current flow. How to measure the current flow? The current flow based on the scientific reasoning is we should connect it the multimeter in serial way. That's the assumption. That's the scientific reasoning to measure the current flow. It is not possible if we connected the multimeter here parallel way. For example, this is a multimeter. In parallel way, we never get the current flow here. That's kind of scientific reasoning related to the method or assumption that we use. Okay, any question, RD? RD? Who is asking?
Yes, sir. Yes.
Yeah. Okay. Any questions?
I think it's clear, sir. Thank you.
Okay. Okay, if it's clear, okay, this is good. Any other question? Any other question, please?
Nothing for me now, sir.
No. Okay. If no, I will ask you. Yeah, because we are approaching the end of this class. Yeah. Maybe I want to asking some of you. I mean, opinion. Asking. Yeah. Knowing the understanding of yours. Okay. I'm asking to Taufik. Kuizita Taufik. Kuizita Taufik, are you ready? Hello, are you there? Are you sleeping? Hello, Kuizita Taufik. Hello, hello. Hello. Oh.